Okay, the Module 5 skill builder entitled Density. Um, so what is density? Density is essentially how much something weighs per unit volume. So imagine you've got a lump of lead that is the same size as a sponge. Now think about that. Which is going to have more mass? The lead is, right? It's going to be heavier. The Earth is going to pull on its mass with more force. That tells us, okay, yeah, there's more mass there for the same volume as the pillow material or the sponge material, right? So we would say the one is less dense than the other. Well, that's the whole point of this activity. Now notice we're not only talking about the density of an object, we're also talking about the density of the fluid that the object is submerged in. So in this case, when you first open up the simulation, you're going to see the fluid density of the fluid in the material in the beaker here is 2.5 grams per milliliter. What that means is if we could take a sample of this fluid, 1 milliliter of this fluid, that's the same thing as 1 cubic centimeter. If we could put it on a balance, the balance would read 2.5 grams. So every milliliter of this fluid has a mass of 2.5 grams. That's what fluid density means. Now this is not water, as we're going to find out. Water has a different density. But we'll leave it as this mystery fluid for the time being. Now notice what happens when I drop my mystery object into the mystery fluid. Notice that there's a reason why these values are given over here. Notice that as we start at 25.5, after I submerge the block, the water or the fluid level goes up, right? Well, that's because, as Archimedes figured out, submerged objects displace fluid. The amount of this object that is below the water's surface is pushing fluid out of its way, and therefore the fluid level rises. Okay, so I want you to just kind of play around with this activity. Check this out. Now notice that our fluid level right now is at 26.5 milliliters. We started out at 25.5, right? Now, watch what happens when I change this fluid. Instead of being the mystery fluid that's currently filling the container, let me turn into water. Notice what happens. My mystery block still floats, but it floats lower in the water now. Because notice now my fluid density is water. Water has a density of 1 gram per milliliter. That means that 1 milliliter, 1 cubic centimeter of this water, if I put it on a balance, would have a mass of 1 gram. And so notice that, yes, my block does float, but it has to submerge more of itself in order to float. And again, pay attention to Archimedes' principle to help you understand why that is. The reason why things float, you can use two arguments, the density argument and the buoyant force argument. I prefer the buoyant force argument. We spent a lot of time a couple of modules ago talking about force diagrams. And really, think about that block. Why is that block, why was it falling just a second ago, and now it's not falling anymore, right? It's an object that's not in motion. It's not in motion not because there are no forces acting on it, but because the forces acting on it are balanced. We know there's a force downward. That block still has mass and the Earth is still pulling on it, and yet there's something else that's supporting it. It turns out the force that's supporting it is what's called the buoyant force. So please do pay attention to that. Other things you can play around with this simulation is you can change the different materials that your object is made out of and see which ones float, which ones don't float in different substances. So you can use water. You can look up the density of different fluids if you want. Look up the density of rubbing alcohol or the density of honey or something like that, and fill your container up with those different materials. So if I reset this, let me put rubber in here. See, rubber floats in this fluid, whatever this mystery fluid is. It's going to sink in something that's like this density, and it's going to easily float in something that's much more dense. So again, play around with these things, and you might want to even try to figure out the density of this mystery block. Find out what its density is, or figure out the density of gold, and then check it. How would you figure out the density of this gold chunk? So these are all good questions for you to kind of ponder on, and you'll get a little more practice with this now in the lab for this module that also deals with this Archimedes principle.